In the next part of our seminar, we're going to be looking at perfect square identities. And here's a case. Here's the proof of the sine squared. It's all the same. Sine squared theta is 1 minus cosine 2 theta all over 2. Cosine, you add 1 plus cosine 2 theta over 2. And then tangent squared is sine over cosine, so it's 1 minus cosine 2 theta over 1 plus cosine 2 theta. Now, on example 3, I want you to rewrite cosecant to the 4th power in terms of cosine of multiple angles with no power greater than 1. Well, the nice part is everything's in terms of cosine. Well, remember, cosecant is actually 1 over sine. I'm going to blow this up because I don't like to write so small. So I can write this as 1 over sine x. That would be cosecant x. Now, how in the world do I get to the 4th power? Well, I know my formula is squared, and if I square that, that would be to the 4th power, wouldn't it? So I'm going to square my square. Now I'm going to rewrite my formula. I'm going to use my perfect square for sine, so it's 1 over 1 minus cosine 2x all over 2, and I'm going to square that. Then let's simplify by getting rid of that 2 in the second denominator, so that ends up in the numerator. So it's 2 over 1 minus cosine 2x, and we're going to square that. Well, when you square 2, you get 4. So then we're going to get 4. And now let's square the binomial. So I'm going to get 1 minus 2 cosine 2x plus cosine squared 2x. Now, I'm almost there. I got everything in terms of cosine, but I got to get rid of that square. So I have another square to get rid of. So now I'm going to write that as, now it's just simplifying. We're not really doing anything other than algebra here. 1 minus 2 cosine 2x plus 1 plus cosine 2 of 2x. Because now my theta is x all over 2. Now we're just going to simplify that. So I'm going to rewrite this as 4 over, let's get a common denominator. Well, my common denominator is going to be 2 down here. So I'm going to have 2 minus 4 cosine 2x plus 1 plus cosine 4x. Now let's simplify that by putting the 2 in this denominator back up here. So it'll be 8 over 2 plus 1. We have some common terms here. 2 plus 1 is 3. So we're going to get 3 minus 4 cosine 2x plus cosine 4x. And there is your answer. Everything's in terms of cosine, and you have no power greater than 1. Now let's take a look at an equation along this line. Let's say in our next problem we got this equation. I got sine squared theta minus cosine 2 theta minus cosine theta equals theta. And I want, oh, that's not theta, folks. That's a 0. Sorry about that. That was a typo in mine. Hopefully by the time, if you printed this off, by the time you get to it, that should be correct. But I'm not going to redo this right now. So I'm going to rewrite sine squared theta as 1 minus cosine 2 theta all over 2 plus cosine 2 theta minus cosine theta equals 0. Now let's get rid of the fraction. So I'm going to have 1 minus cosine 2 theta plus 2 cosine 2 theta minus 2 cosine theta, and that's going to equal to 0. Well, we can simplify that a little bit, can't we? So we're going to get 1 plus cosine 2 theta minus 2 cosine theta equals 0. Well, that 2 theta, that kind of bothers me. So let's rewrite that identity, your double identity from before. So we're going to say 1 plus 2 cosine squared theta minus 1 minus 2 cosine theta equals 0. Well, let's write this in standard form. We're going to get 2 cosine squared theta. Notice your 1's cancel. Minus 2 cosine theta equals 0. Well, we can factor out 2 cosine theta, can't we? So we're going to say 2 cosine theta. Factor that out, and you get cosine theta minus 1 equals 0. So now you got 2 cosine theta equals 0. Or cosine theta equals 1. When does cosine equal 0? And when does cosine equal 1? Well, when cosine is 0, that means theta is, let me see, pi over 2 or 3 pi over 2. Cosine theta equals 1 at 0. Now, I did not restrict this to 0 to 2 pi, did I? So theta then is going to be 2k pi, pi over 2 plus 2k pi. I actually could have said plus pi, but I think I'm going to just keep it consistent. And 3 pi over 2 plus 2k pi. And that's provided k is a member of the integers. So it repeats every 2 pi units.